Thank you, everyone. So today I'll be giving a bit of an overview, project overview of AMRF First Building with a particular focus on designing for country and disassembly, and how some of those ideas and themes are embedded very deeply in the design thinking and the architectural and landscape responses. So the project started in 2021 and is due to complete end of this year at some point. So it's been a 3-year journey with a lot of learnings, a lot of great processes, and something very different to what I've been part of before. So I'm just going to touch briefly on some of those things with a focus on the country and disassembly element. So I'd like to start with a bit of an acknowledgement of country. Today, I'm presenting from Gadi country. We acknowledge and respect the traditional custodians of this land and pay respect to elders past and present whose knowledge and wisdom has and will ensure the continuation of cultures and traditional practices. AMRF First Building is on Darug country, out in Western Sydney, and we recognise that despite being changed, this country is still cared for by the Darug and their ancestors continue to walk this land, and we express our gratitude to elders and knowledge holders whose wisdom, activism, and knowledges have kept culture alive in this place. We recognise our responsibility to respect both this country and those who belong to this country. So yeah, AMRF is that the project site is that dot there, that red dot, and I'm presenting here from Gadi country, the green dot in the city. So the design team and partners on this project, Hassell, were undertaking the landscape, the architecture and workplace. We're sort of mixed discipline firm who do landscape architecture, workplace, and urban design, and we were partnered quite closely with country-led connection to country consultant we work with on most of our projects these days, Jinjama and Danielle Hermek, and also cultural landscape design consultant Jiwa in Clarence, who was supporting the landscape team in translating some of those country-led principles into design responses, and also Paul Gibson Roy, who's a native planting consultant, who was guiding on the native species in that particular place and country. So just a little bit more about the location. AMRF's situated in what they're calling the third city, the Western Parkland city, it sits in the new Aerotropolis precinct, which is a new city, first new city, in fact, in Australia in over 100 years, apparently, I've been told. And it's the Aerotropolis is the new city that's called Bradfield, which is going to sort of start building out around the new airport that's under construction out there. So the project is an advanced manufacturing and research facility. Its brief really is to attract global tech industries to this area and almost form a kind of science park in this space. It will house advanced manufacturing equipment around additive, subtractive, and other sort of complex manufacturing processes. Client is the government, the Western Parkland Authority, also known as the BDA now. The head contractor is Taylor's Construction. The structural engineer was Enstruct, Mech and Elec were NDY, and fire services and fire engineering was by Arup. Key subcontractors that have sort of contributed to this presentation today are Savcon and Northrop on the timber side, Steel, Dunn Steel, and Facade High Tech. So I wanted to start this presentation by acknowledging the process that we've been through with connecting to country. And the start of that was the two key natural drivers for this place, this country, which is the Cumberland Plain. It's characterized strongly by tree stands and woodlands among sort of flowing grassy plains. And I just remember my first visit there, and it's a very beautiful natural place, very tranquil, very calming, with an abundance of wildlife. The second predominant feature is the Wainemata, and this is a kind of almost a hidden network of waterways in the area, a very vast network, which really just highlights how important water is to this country, this place. And the start of that is also looking at the name Wainemata, which Waina means mother's place, and matter means water place. So it has this name which has a deeper meaning about the cultural importance of these natural formations. So designing with country, this is just I'm just going to talk a little bit about the process that we undertook with Ginjama. So we started at the very beginning of the project. We were sort of engaged at the same time. We engaged Danielle as a sub consultant for this project, and we walked country together. We sang to country, and we tried to listen quite deeply to country. And some prominent sort of things that happened in that process was the discovery of a grandmother tree in the sort of vicinity of the site, which had a real importance to the design team and to Ginjama and Danielle. There was a face visible in the tree. It was about this kind of sense of collective well-being, and looking after that tree was very important, and understanding what it was doing collectively for this area. And this is sort of the process that Danielle undertakes from sort of design concept to sort of seeing the project through. And she was advising us right throughout the project. We were having reviews with her, testing ideas, discussing our responses, and to her sort of narratives that she'd presented to us. So in terms of the narratives, she sort of, after that initial process of walking country and listening to country, Danielle goes away and she does a lot of local engagement, a lot of research, and then presents back to us this sort of narrative matrix, which becomes our sort of Bible, really, in terms of what we cross-check our design decisions against. So I'm just going to highlight the important ones, which is the water story, obviously, the maternal story, which comes with that, healing country, ingenuity of country, relational materials, belonging and cycles. And within these, there are key principles that we've sort of used as generators for some of the main design concepts. So obviously the water being the fluid lines, the carved forms, emphasizing the sort of the maternal story and the softness of built form. But also, yeah, we asked ourselves questions like, what is it to manufacture within country, and what does that response mean? Nature is very innovative in its own way, and I think we were trying to talk back to that in terms of, nature does often have the answers, and it provides a lot of insight beyond our own knowledge and understandings. Relational materials, so really being clever and with finding innovative ways to use very local natural materials that are of this place, such as timber and rammed earth, and embracing cultural practice of this place, and then also the cycles of ecology, which we found very interesting with paradigms with the circular economy, and I'll talk a bit more about that later. So as this is a landscape-led project, really. The landscape really was a driver behind everything. So the initial concept, which our team developed, was sort of an overlaying of the Cumberland Plain and the Waitemata. So those meandering tributaries and the tree stands of Cumberland Plain, and how they come together, and what that might mean in kind of a concept and a beginning of a concept for the first building and the landscape around. And these are some of the design responses which started to come out of that thinking. The fluid lines of Waitemata, celebrating water, so bringing people, making people aware of the importance of water in this area, connecting to water, so bringing people close to it, and then cleaning water. There's a series of natural basins within the landscape design, and the importance of that filtering of clean water into the creek networks is of high importance to the natural systems and preserving the ecology of this place. And in terms of the architectural response, the way we started thinking about that was really building on those landscape-led and country-led principles, and starting to really think about the character of this place, the character of Cumberland, we call it. So the designs sort of started to form around the tree stands and light quality. So the columns were representing tree stands, and the canopy of the roof was representing the canopies of the trees in a way. So it was a pavilion form that was quite early on defined, with an emphasis on material sourcing, texture, utility, and sustainability principles. And then obviously that landscape-led approach where building was the recessive element. It was a backdrop to this beautiful country. It touched the ground lightly. It almost let the landscape flow through and under its roof, with immense visual connection to nature within the building. So I think from every point in the building, you can see trees beyond, apart from when you're in the core, obviously. And yeah, it's really the building's not imposing on that landscape at all. And then a bit about the sort of response to the brief as well, and how the questions around what is manufacturing in country. So what we call the production spectacle was really a way of highlighting, emphasizing processes and the operations within the building, and the manufacturing on display, which we thought was a great education tool potentially, and really a way to engage the community in the processes that were taking place. So you can actually traverse on all four sides the manufacturing hall, and walk around and look inside, and get an understanding of what's going on. And then interestingly, the fourth one was about responding to future context. So this being in the future an urban pavilion, there's currently nothing else built in this area. So this will be the first building for a number of years. I think the AMRF 2 and the station to the southeast will come online in 2026. So it presented an interesting challenge designing a building for a future context. And we kind of wanted this to be a low density, low rise project, which might become more of a public heart to this future city that will have more scale around it in the future. And these are just some early renders of the project, which start to show the formulation of those ideas, those landscape ideas, those built form principles that culminated in a response, an overall response. A green roof, kind of visual connection into the manufacturing hall, meandering soft lines, soft corners, meandering pathways, and an emphasis on the landscape really, with the building just being part of that country, part of that place, part of that landscape. So this is just a shot, a visualization inside the building. This is the sort of lobby. It's we call it the central connecting spine. There's a 2-meter drop in levels from east to west on this project, and this space is a transitional space lobby which connects all of the different floor levels of this building in one sort of very gradual walkway, slowly sloping walkway. And it's a connecting element, but it's also the landscape comes through the building. So the paving condition and the planting condition flows through the middle of the space, separating the two functions of workplace on the north and manufacturing hall on the south. And this space will be used for a variety of functions. It'll be an event space with talks and presentations and exhibitions and all sorts of other educational purposes. And there's just this idea of an indoor-outdoor space, quality of light, trying to again touch on that character of this place, character of Cumberland Plain, by emphasizing dappled light and obviously the materiality in the timber. A little bit about the program. So yeah, the program is 1,400 square meters of workplace. That'll house sort of the operational team, AMRF operational team for the manufacturing hall, the researchers and equipment workers. And there's a mezzanine above this level and a viewing platform on the roof. I haven't showed a floor plan for those, but it's essentially a workplace for different tech groups to come in, maybe project by project based, and come in and use the facility for specific projects. Central spine, I've gone through that, and then the manufacturing hall, which is 1,000 square meters of equipment, robotics, and other things. So now moving into the roof design. Um, so Ginjama, quite early on in the project, presented to us some locally made, traditionally made, locally made objects such as fishing nets, which were of particular type and construction unique to this country. Um, and that sort of formed the basis of our exploration around some of the structural expression of the roof structure, looking at how we might weave and layer the structure, creating and looking at like the mechanical fixings and the nodes similar to the nets and how they might be bound together. Um, so yeah, the that's the formation of the structural system, which is a grillage. Um, and it behaves much like a net, forming a plane and spreading and distributing loads quite very evenly, actually. This is just an image, current kind of construction image taken on site a few weeks ago, which just starts to explain, other connection to country design elements that have been incorporated, such as the no sharp corners, so a real carved feeling to the building, soft corners, soft edges, so that it really fits in with this place and this country and some of those narrative matrices that we were discussing earlier. So a bit more on the structural system. Um, so we started by we wanted to really analyze what we were doing structurally from an efficiency point of view, but also for what the project really needs. So this on the far left here, conventional would be an 18 by 9 grid. 18 is the largest span in the manufacturing hall. What we found with this is going to a 9-meter grid, doubled the size of the timber cassette. So the cassette system you can see here, the lighter timber that sits above the darker timber is the cassette system forming the roof deck. And that actually doubled in timber volume if we did a more conventional system with a 15% increase in overall timber. Then we looked into things like, well, what if we obviously, half the grid to a 4.5 in the east-west, but that did provide a reduction in timber, about 14%, but it also increased the steel columns by 65%, which is a huge embodied carbon impact. And it also reduced the flexibility of the floor plan for the manufacturing equipment, which the client really wasn't happy about, because they wanted to provide that maximum flexibility, and the equipment goes in between those structural bays, and it reduced floor area quite drastically. Thirdly, we looked into sort of just a transferring of the beams at the 4.5, similar timber volume to what we've got currently as the sort of final solution, but there were 30% greater deflections, which was a bit of an issue for some of the things that were happening on the roof, and it also was a 20% increase in structural depth, so the whole thing would have got a lot deeper. So where we ended up was this grillage, which is quite unique, and it was responding very, very closely to the ideas of the woven net, and but it also had some very practical benefits, such as those evenly distributed loads and forces, and providing that 30% reduction in deflections and a reduced overall structural depth because of that. So it was a very interesting to see the results coming out of that structural testing and that engineering, that it was forming this very rigid plane, and providing quite a lot of benefit in terms of deflections. So this is just some of the deflection graphs that we use to analyze these structural systems. Number 4 there, the grillage to the bottom left, is showing a 30% greater less reduction in those deflections. And really that was benefiting this project because we had a green roof that was irrigated on top of this. We have a large number of PVs and skylights. So there was actually quite a bit of load on that roof, and we had to maintain good long-term deflections as well, because there was a gantry, 15-ton gantry crane traversing up and down the manufacturing hall that we didn't want to ever get too close to with any deflections. So the layering of the structure is also quite interesting to discuss. So there are 2 options with the grillage. You can do a grillage in one plane, which is the image to the left, and that has some issues, which we found, which is it is actually very expensive to get continuous connections through the beams. And breaking the beams at the primary location loses a lot of that deflection benefit that you're getting. So we looked into the layering option, and building the grill in 2 layers, and it actually made installation a lot more efficient. So it's actually a lot easier to build on site, and the connections can be greatly simplified, and more sort of more simplistic, cheaper to build, I think. Um, and the split beams as well, which is something I'll discuss in a sec, allowed us to pre-assemble these beams on the ground, with the connection nodes, meaning there's no increase in crane lifts in this option either. And that deflection graph at the top there, on the top right hand side, just starts to show that the lower beams are actually pulling the upper beams giving them strength, pulling them down, and creating this uniform plane, almost like a floor slab in a way, um, providing the roof with great rigidity, in doing so, which is reflected in those deflection graphs. So a little bit now, moving into a bit more detail on the beams themselves. So I'm going to talk a bit about lamellar efficiencies, and the importance of this actually at the early phases of design, because it can make a great impact on cost, process cost, installation, and actually it would have a great benefit if these things are known early on. It can help us get more timber projects through, I think, because we're tapping into that expertise, which is, we have access to within our engineers and supply chain, and we can actually make these decisions and let our clients know that there are savings available, if we do things in a clever way. So selecting the right lamella, based off the feedstock, it does have a significant impact on cost in terms of processing. So we ended up with a 125 single lamella, which obviously is good for the feedstock. If we'd gone for a 250, there would lamella, they'd have to be glued, and the factory processing and material processing would add a 20 to 30% cost. And then we decided to go with the split beam, because of that reduced factory processing and the reduction in glue used due to there being no block gluing. So that also helped us with our mechanical fixings as well, and how to easily bolt through these split beams and connect columns up through as well. So it was a whole range of decisions, but actually it was much more time and cost effective to go with the split beam solution due to the single lamella, which has been a great benefit to this project, I think. And this is just an image to show how these beams are assembled on the ground. The two beams are actually bolted together quite quickly on the ground with the mechanical connection, and then lifted into place and bolted off. So one of the key principles that came out of that we were designing to was being flexible and adaptable, and looking at those cycles of ecology and seeing how they're reflected in the principles of circularity. So we're designing a modular kit of parts. It's a very, very standardized construction system. There are a handful of details. We're trying to get that repetition through that modularity through to help with the efficiencies as well. So leaning heavily on the on mechanical connections and bolted connections, to do that. And yet, the whole process of designing for disassembly, was crucial to the whole project, and these mechanical fixings, they allow the components to be unbolted, and moved even in the future. So the components and the building could potentially move sites, or the components can be reused and easily recycled. So trying to extend the lifespan of these products and materials and components, and that's part of the circular thinking of this project. And these images just start to show that sort of modularity and how that gives you benefit in the sequencing on site, and how the structure quite easily grows from one side to another. I thought this was quite an interesting shot where it just shows it stops at the manufacturing hall before they start laying the next layer of beams. So mechanical fixings, we chose to express the fixings. It was part of the design intent and language. We were really quite keen on expressing the bolted connections, showing that idea that, this is something that disassembles. And that was key to the design language and responses that we made. So what we were doing, we have intermediate beams, which are cleated off the cruciform column, which I'll talk about in a minute. And then the steel SHS, what we call the through connection through the beams. So we've got the head connection of the column, which goes through a sort of pin joint connection through the two columns, two beams. And that's all bolted off to form one system. So the column design was really interesting and really important to the disassembly, the success of the disassembly and how we detailed this building. But I'll just quickly talk about, we did the initial intent for this project was to have fully Australian sourced timber, 100% Australian sourced timber building. That was the original design intent. I'll talk a bit more about that later, but to do that with a column, have a solid timber circular column would require a 600 diameter. And we were informed that's not available. There wasn't the milling equipment in Australia to deliver that. So that kind of put us off at that early stage. But there were also issues with the bending moments from the gantry crane and other things. So the steel came in then as we started exploring a steel column, while still trying to maintain some of the timber appearance and feeling of the column. So we looked at encasing a steel cruciform, which we're looking at a cruciform because of our pleat detailing and how we bolt beams onto these columns. But it became a 650 diameter with a full sheathing of timber because we needed to allow a char depth to protect all of that steel with the timber to work from a fire engineering point. But actually, when we got into the detail with the fire engineers, it's not a tested system in any way, and it was presenting quite a few obstacles. So what we ended up with was one on the far right, which is a steel cruciform with timber infill corners, and those corners are offset 50 mil for intramucent paint expansion. But they also it was really nice because the bolted pleated connections just slotted right into those gaps, and allowed us to sort of express those disassembly junctions even more and show a bit of the concept in this detailing. And this is just how some of that detailing turned out in the detailed design with Savcon and Northrop, and yeah, just showing there that how those timber corners are fixed onto the column, and then how those beam cleats come off the flange of the cruciform, and the SHS there going up through the middle of the split beams. And these are just some construction process images of those details on site and how they're starting to come together and look. You'll see in the middle we have a mezzanine pleated off the cruciform column, and then the image on the far right just shows sort of almost a final condition of the mezzanine beams pleating onto the cruciform columns with the timber corners fixed onto the column. So I think what we found and what we know as well, I think, is that the power of a digital model in these timber constructions is really important, and the BIM process and LOD 400 and getting everyone on board, especially the key trades on board with that, with good workflow is imperative to the success of these timber projects. We were lucky enough to work with some fantastic subcontractors in this project, such as Savcon doing the timber and Dunsteel doing the steel, and they really embraced the power of the digital model, which was great. And that allowed us to ensure that there were no issues with the fabrication of the steel and timber. There were no issues on site really, not that they told me about anyway. I think we reviewed every single bolt hole to ensure that it was fabricated, and there's a lot of bolts in this project. I think we missed 3. So visually in 3D, reviewing all the junctions and the detailing, which the production drawings, the fabrication drawings are taken off the BIM models, it is incredibly important and saves so much time and money and risk on site. Which is something we're a big advocate of, is this process and how it is essential for prefabricated buildings. So a bit now just about the construction time. We think that something that we're dealing with, we're trying to kind of position or create a position on construction time and the savings that need to start being reflected in construction programs and tenders more accurately. We have found with a lot of timber projects in our office that quite early on, costing of timber is scaring people quite a bit, but it's pretty inaccurate at the moment, and there are very few QSs around that have that ability to experience and ability to accurately cost these types of projects. But yeah, what we found, there are tangible savings in prefabricated timber construction. Concrete on this project we have a in ground, and the plinth is 16 weeks, and then steel was 2 weeks, the columns, with a bit of bracing. And the timber was 4 weeks. So there are huge savings in terms of getting the structures up very quickly that aren't being factored in properly to the tenders, which is causing some problems, I think. And we're trying to sort of leverage our connections in the industry and with engineers and experts to actually myth bust some of these things that are preventing timber projects getting off the ground. And because timber can be cost neutral, but you just have to have clever engineering, clever design, accurate costing. But I think they can. I know there is a premium on the timber product itself, but there is a way, even now, with that premium, to design cost neutral timber buildings. And we have seen examples of that from some of our partners that have shared things with us, engineers and the like. And now quickly a bit about services. So yeah, there's a really what happened on this project. What we wanted to do, we wanted to mitigate any issues in knowing this is a tight D&C program, and timber has a very long lead time. We thought very early on very hard about clear servicing strategies that can create maximum flexibility for the detailed services design phases. So yeah, what happened on this job, which we kind of expected, was that the services trades were not engaged with the timber trade, so that we were designing detailed timber without services and some of the other key trades, in fact, at the same time. So we had to really come up with a solution which was really designing a timber structure without penetration needed. And I think that's really interesting as well. If you can do that, it has a great beauty to it as well. I think a benefit of not creating penetrations everywhere, especially when timber's exposed in projects. So yeah, we were creating clear servicing strategies that were developed alongside the structural side of development of the project. And I'll just talk a bit about that now. So we've got a clear east-west, north-south divide between different types of services. Fire services, primary feeders in the red there, run in the grillage layer, north-south. And then the secondaries run, all the sprinkler heads and the secondary feed run east-west within the top cassette, hidden kind of almost in the top cassette layer. And then the sort of exposed mechanical ducts in the manufacturing hall run in the grillage at the lower level, which there's space to in the lower level of the grillage, east-west. And that's just how some of those systems look. So as I was saying there, the blue dot is the mechanical vents running in the lower east-west. We have a gantry crane just below the grillage there. So the duct runs nicely up, clear of that gantry crane that runs throughout the hall. So thinking quite carefully around how you take services up to this level in order to mitigate clash with things like gantry cranes in a working manufacturing facility. And then up in the cassette right at the top there, we're hiding a lot of the fixtures. So we've got smoke detectors between those cassette rafters. We've got sprinkler heads and sprinkler runs and cables. And what we did, we actually took it on ourselves, knowing that this services expression is really important. We took it on ourselves to to draw every single plan with all the services drawn on there. So we actually issued a services Bible to the team and had located every single pipe, cable, and fixture to ensure. And obviously they checked that it was all, there was enough. We're using their sort of parameters, design parameters around that. But that really helped with cleaning things up. And even things like lights and other services are integrated between split beams. And this is just an image of how that's starting to look on site. And I'm quite happy with how clean the services is looking. There's a really nice rationale and layout to everything, and a reason, a logic, which you're starting to see here on site, which is great. Over in the workplace side, we didn't want to express a lot of the services as much. We really wanted to clean it up and keep that timber as beautiful as possible. So we went with a displacement air system. So we've got a floor plenum, which distributes air through the workplace, pumped in from the core, through fan tiles. And then we've got various other services reticulation within that floor zone to really clean things up. A bit on ESD targets. So this building is on track for targeting 6-star Green Star, and it also undertook the Living Building Challenge, which was a very interesting process. I've never done it before to undertake, and we took it quite far. However, I'm not sure totally what exact petals it's going for now. It's definitely not going for full certification, I don't believe, but it was a very powerful, I found it a very powerful piece of advocacy. It was really great to see the way the way it interrogates the supply chain. So you have to ask a lot of questions through the whole supply chain in terms of red list materials, sourcing, distance to site, all those sorts of things. And it really got the supply chain thinking, and subcontractors, consultants, the supply chain. Everyone was sort of changing the way they were thinking. And, if they want to work on projects with Living Building Challenge, they have to actually change how they do things, which is a really powerful piece of advocacy that I saw tangible benefits from just in going through the process on First Building. There were some contradictions. It is an American certification built for houses mainly. So translating that to the Australian market onto large scale projects, there were some teething issues with it. And I think I'll talk a bit more about that in terms of the timber sourcing in a second, but there were some contradictions there. And I think does need to mature a little bit for other markets, other outside of the US. But a great, powerful piece of advocacy that has done so much for the project, even whilst it's not going for the full certification. It's also targeting 5.5-star neighbors as well. So a bit of quickly on the materials revolution side of things. Yeah, we really wanted to, the whole LBC process actually triggered a bit of internal research as well on a kind of a materials revolution, and how we can really change our thinking on the materials we specify and where they come from and what they're made from. And that really started initially with a bit of discussion around country, obviously, and we started looking at the ground conditions, the surface conditions, and then the geotechnical soil samples of the site to produce a little bit of a color palette, what we call a country color palette for the project, which did inform every decision really around what materials we were selecting, but also what was there. So the timber, the trees and the timber, and the earth, and the clays in the ground. So the ground had quite a high clay content, and we did talk to that in selecting rammed earth as a product for this project. And we went around a couple of the local factories that were doing rammed earth, and trying to understand their processes, what they could do, what they could make, and really tap into that on this project. So this company here they're making prefabricated panels of rammed earth. They're making these cylindrical seats for the landscape. We're actually using the cylindrical seats in the landscape. I'll talk a bit more about the panels in a sec. But connecting with local supply chain to use local materials and local manufacturers. So the core is interesting, and we decided to use the rammed earth on the core, and the core actually disassembles too. So I don't know, not many cores disassemble. They're usually concrete. It is a steel core, so the steel columns, the cruciform columns. Um, but we decided to clad the core in rammed earth panels as a grounding element to the building, to really speak back to the earth that is of this site and the earth of this country. So yeah, these panels, we did intend initially for them to be prefabricated, but there were certain issues around the weight, size, and lifting of these panels. Um, so they are actually in situ panels. They are rammed in situ, but they're rammed in a frame, which is bolted back to the structure. So they do disassemble these panels still unclipped. God knows how you would move them, but they do disassemble and can actually be taken away or replaced and moved. And yeah, the detailing was quite important to achieving that. But a similar methodology to the timber columns as well, and just sort of expanding that to the core. So quickly on timber, sourcing and product. So the original intent, as I mentioned, was 100% Australian timber, and the client and ourselves were really in support of that to support and help grow and develop local supply chain, which is critical for us to become self-sufficient in our materials that we use in projects in Australia. However, as I was mentioning, the Living Building Challenge requirement came to fruition, which was requiring a 50% of the timber to be FSC certified, which means you have to source it from overseas, which is a huge contradiction. I mean, I know currently the embodied carbon of the shipping is very similar to the trucking it from somewhere in Australia, but it does seem in contradiction, being pushed to source timber from overseas. And we did go for a clarification on that, but they were pretty hard on that requirement on FSC. So the cassettes, the floor plates, the CLT, the battens, and the flooring all then came from overseas. But we managed to maintain the main structural elements such as the beams, the columns, and the facade systems and the internal partitions, all to be locally sourced from ash and Vic Beam, which was great to support those local based companies. Um, Other initiatives we were kind of exploring through the project. This one didn't get into the project. It was something that came in a bit after tender, so it didn't manage to get through. But we had timber partition specified, so that's what we've got. We've got the Vic Beam timber partition system, but it's not this Clickwood system. However, it's still demountable in a way. But something we've been exploring as a practice is demountable things, things that come apart, things that can be recycled and reused. So demountable partitions. This was developed by one of our interior design principals, David Whitaker, with in collaboration with Clickwood, who are traditionally a kitchen joiner, who are now have moved into the partitioning space. And it's a really fantastic system. That all the timber can clip off and disassemble. So it's sort of a self-build system in a way. And yeah, we're using it on a lot of projects, and it's this cost neutral with an aluminium system. So that was what it was designed to be. All the partitioning that we traditionally did was always coming in as aluminium from a cost point of view, and this has started to solve that, which is really great to see. Other people we're partnering with, we're really, really strong on partnering with local people who are doing great innovation in the material space. So UNSW Smart Materials, we're using the green ceramics for AMRF, which is all fully recycled content, recycled glass, and recycled fabric. And it's great to go to their factory and talk to them about the project. And you select the fabric, you select the color of the glass, and you can get a very unique product for your project. And they are manufacturing these on scale at the moment in a factory somewhere in southern Sydney. And another product that we found, quite interesting was DuraPanel, which is the compressed straw as insulation, to be used as insulation and acoustic insulation, thermal insulation. Again, something that didn't come to fruition on AMRF, but something that we started to look into quite closely. So just to wrap up, really, I mean, this is Bill Sharp's Three Horizons framework, and AMRF was really the main goal for AMRF was to advocate for change in the construction industry and to do something quite unique, set a standard for the new city of Bradfield, for other projects to follow, and hopefully look back at AMRF as a great project that's leading the way in that change and that sustainable regenerative thinking. So what we hope is that that blue line there. So the red line is business as usual. The blue line is these innovative ideas or projects that contribute to a viable future. And what we hope is the AMRF First Building is one of those disruptors along that red line, and it sits on that blue curve to push us all towards a collective, more viable future. So, yeah, thank you. Thanks, Alistair.
That was great. Thanks, Yann. So please, anyone, if they have some questions, post your questions just in the Q&A tab there, and we can certainly address those as we go forward. But no, amazing project. Thanks, Yann. I was certainly sort of taken with particularly the sort of thoughts around designing for country and all the sort of work you did there. It was interesting with the Living Building Challenge. Were they interested in any of that, particularly from this Australian context?
Yeah, it did form a part of the accreditation. I can't remember which petal, but it did go towards some of the credits. Yes, yeah, it was
Okay.
considered as I can't remember exactly which of the petals it was going under, but it was definitely written up. Yeah.
Okay. We did have a question there about the is the ceramic with the recycled content fabric a fireproof material?
Yeah, I believe it is. I mean, it's a tile, so it's a tiling product. We're using it as it's in the wet areas, so it's in the amenities, floor tiles and wall tiles. So yeah, it's recycled glass, and I believe glass is fire retardant. So yes, it is.
Mm. You talked about, with as you worked sort of with the design team about thinking about design deconstruction and your modular kit of parts and those sort of concepts. Have you started to document stuff like that so you can use the same ideas through projects sort of moving forward?
Yeah, we are. I mean, we have used AMRF as an internal piece of research in a way, and it is starting. It hasn't quite got there yet, but in terms of our rolling out a materials process and a materials research database for projects is something that we're looking to do on the basis of the work that we've done through AMRF. I think the detailing, I think more maybe not the detailing, but the principles of disassembly and the circular economy are definitely being carried through all of our projects now. We at the start of every project we have a regenerative design workshop, and we have an in-house sustainability team, and they run those now. And all these ideas are explored for every project, and timber is always looked at as a viable solution. And yeah, I think the detailing is something on this project that's quite unique, but definitely bolted connections is something that we're exploring on all projects.
Mm-hmm. You didn't have a sort of image of the detail in your presentation, but I thought this question was going to get asked. I must admit, I was thinking of myself when you spoke about it, but you mentioned it's a green irrigated roof. So,
Mm.
yeah, what approach did you use there in terms of ensuring you got the right membranes to protect that against sort of water
Yeah.
penetration?
Yeah. The waterproofing of the roof is obviously very important. But what we've done, we've put we put the gutters outside of the dry line, so all the weak points are actually outside on the canopy. So there's a 4.5 meter cantilever around each side of the building, and so that the gutters are in that zone. So if there is a leak, which is in the weak point, it wouldn't be inside the building and in the high value areas. So that was one initial strategy about planning the location of our, gutters and hydraulic strategy. All the falls on the roof are created in a rigid insulation, so that the insulation is the element that's falling. So on top of the set deck, there's there's a sheet of FC to help with our fire engineering, and then over that an initial primary, or maybe it's the secondary membrane actually there. And that's just so there's a membrane, there's a membrane there, and then the insulation goes on top, and then there's a membrane to falls, and then there's the green roof. So it's double, triple protected in terms of membranes. There's two to three layers in there, which I think the client's also considering using moisture sensors on the soffit of the roof, and just to check to monitor the moisture content of the timbers. Which will tell you quite quickly if there's an issue. But yeah, there shouldn't be. There's a lot of protection up there.
Mm-hmm. I notice we also have as participants Ali and Matthew, who are engineers on the project. I'm not sure if they want to unmute, if they'd like to chat also about it. But yeah, no, it was really sort of interesting, your discussion about the engineering side of and how you sort of worked it up and finally got to the grillage. I mean, I think with all timber buildings, one of the key things is about that sort of early contractor involvement and having everyone discuss the timber system. I'm not sure if Ali, you want to sort of talk a little bit about that you work with Hassell and also with Savcon, you know, the installer, to ensure that everything went smoothly.
Yeah, so can you hear me?
Yeah.
Ali couldn't join, unfortunately, but he passed on to me. I work with Ali, and I worked on this building alongside with him. And was talking to Yann about the structural optimization stuff a couple of weeks ago to kind of go through that. I guess it was really it was a great project to work on, you know, for us. I guess from the contractor involvement side, we were engaged by Savcon, who are the timber installers, to sort of complete the design and go through all the sort of nitty-gritty things, which I guess, as people who have worked on timber know, it's almost always the most important part, right? The actually fitting in all the bolts and making sure it's actually can be assembled in a sort of timely and safe way is actually often the much harder part than sizing the members and making sure everything actually fits in the building, actually having them fit together, and particularly for a building like this, which is designed to be assembled quickly and disassembled, was very challenging. And one thing that I guess I would add in as far as that area of assembly and disassembly goes was just the layering approach of these grillage members was probably the most, I suppose, complex part for us to work out in the from a construction staging point of view. Like, if you can imagine, some of the members support the other ones, but then if you go to the next member over, that support sort of flips over. So you can see there, the ones that land on columns have to go in first, obviously, but the member right next to that can't go in first because there's nothing to actually support it. So working through that process is something that, you know, can only really be done when the whole team is together working it out. It's not something that can be done individually by, say, the architect. It's not something that we could do individually without input from the contractor, because how you actually lift these things up and into place and fix them off is something that you really need a specialist like Savcon to be involved in that discussion and talk about it. And then that goes back to then affect the design of the individual members as well. So it is this kind of complex cyclical design process, but yeah, it was really enjoyable.
And I'd also imagine the importance of, you know, with the timber supplier. I know Australian Sustainable Hardwoods have got a great design team down there that's, you know, always sort of willing to assist to come up with the right sort of outcome to meet the timber product.
Absolutely, it's quite a complex, I guess, relationship that has to sort of occur between a lot of different parties to get the thing over the line, and it's something that, you know, is fairly new, I suppose, to the Australian market as well. So Australian Sustainable Hardwoods do a great job in that part of the coordination process as well, because not only do you have to lift into place, but the actual final confirmation that, you know, you can actually fabricate this thing, that it's suitable for their machinery and doesn't require milling or cutting that's, you know, extremely expensive or time consuming, is a really important thing. And that sort of feedback goes both ways, that it can come from the timber manufacturer back to the installer, or go the other way. And I think, you know, as Yann might be aware, the architects and the engineers actually end up getting caught in the middle of it a lot of the time. But an enjoyable process.
Always needs a good team effort to get a successful project. Now, look, thanks everyone for participating in today. And Yann, thanks for a terrific presentation.
So thank you.
Sort of just about up on time. So yeah, thank you once again. I'll just remind everyone that the webinars are all recorded, so you can come back and have a look at this again afterwards, or recommend it to any of your colleagues. In a month's time, on Tuesday the 6th of August, our next WoodSolutions webinar is all about short and long-term performance of reinforced timber frames from the lab to design, and Professor Gudazi from University of New South Wales will be speaking on that one, so really look forward to that one. So thanks everyone for attending today. Been a great webinar, really appreciate it, Yann, and everyone have a great week, and we'll see you at the next webinar.